In this video, I want to get into real-time spectrum analyzer mode and show you some Bluetooth measurements. So let's get to it. So the first thing is mode measure is, if I want to get in RTSA mode, I can do that manually here. And in RTSA mode, if we go into sweep, we can see that I have a choice of 40 megahertz band, 10 megahertz band, in advanced mode, 100 megahertz span. And the reason that 100 megahertz span is in advanced mode is because it uses a 0IF receiver front end instead of a super heterodyne front end, and you have to be careful of IQ offset and any images that could arise in a ZIF mode, 0IF mode. So you have to be careful of that. And so it's recommended for advanced users. But we'll show you how useful it is. So we'll go into load settings and look at a pre-configured ISM band, 2400 megahertz, looking at the Bluetooth band or Wi-Fi band. And we already have it going. Have two Bluetooth devices going, a low power Bluetooth device, if you can see here, lower level signals, which is my Bluetooth mouse, and higher peaks, which are my Bluetooth speaker for my audio MP3 player out of my mobile phone. We see some Wi-Fi popping up here and there, and that's from around the neighborhood. I have it off here in the house right now. And you can see some of the Wi-Fi coming and going. So what we have here is a spectrum display. We have the spectrogram display in the middle and the persistence plot. And we're showing the different views that you can see all at one time. Also, you can change the colors you want for any of these. You can pick pre-loaded palettes or change the color of any of these ticks that would suit your eyes or for the measurements that you want to make. Down here is a persistence display, the same thing. You can change the color palette, and the yellow or the gold is showing where the RF energy is being persisted at most of the time, and the dark blue is where it's at the least amount of the time. And you can see the hopping pattern of the Bluetooth here over time with the spectrogram. We'll get this cursor out of the way here, and now you can see making measurements. Now we have the real-time level trigger on in the start and stop frequencies of that, and you can change that to different frequencies if you want. We have a real wide band 802.11n frequency going on there right now, good 40 megahertz signal. So there's somebody out there with a high-end Wi-Fi access point. So that gives you an idea of making measurements there. And the level trigger, let's change that level trigger. You can change its level and only fire on signals of certain magnitude. You get down here and it's going to be firing on everything. And up here you can see the Bluetooth, more of the Bluetooth as you change the level. So that's a quick snapshot of making RTSA measurements. Again, you can pick what span you want, 40, 10, or 100 megahertz, and see with the spectrogram where, in this case, the hopping patterns of the Bluetooth are going, and they're in 1 megahertz steps as they randomly or adaptively hop around, trying to avoid the Wi-Fi as much as possible if they're strong signals. But they're pretty weak, the Wi-Fi signals, relative to the Bluetooth signals. And the Wi-Fi is coming and going here in the neighborhood. Okay, thank you for your time.